Is an introduction to serverless applications, and don't worry, I'm going to explain what that means. It's specifically AWS focused, and I'm going to jump right into it. So what I'm going to cover in this talk is what's happening right now. What does serverless mean? What's going on with this whole trend? Why do people keep using this buzzword? Next up is why I think it's going to empower this audience in particular. Why I think it's especially meaningful for all of you. And then after that, we're going to get into a demo of how to actually start doing serverless application development. Quick intro on myself. I'm Austin. I live here in the Bay Area. I live in San Francisco. I'm from Los Angeles. I'm a self-taught engineer. I was a platform hacker when I was 16. I was very focused on like Drupal and the PHP, my bulletin board project. And from there I grew out and started messing with a lot of other tools and languages and stuff. And today I founded a company, a startup, and I'm the CEO of that startup. We have 17 people. We're located in downtown San Francisco. We're called Serverless Inc. And it's been a hell of a journey, I'll tell you. But I like this audience in particular because I think I know what you do. And I did that for a very, very long time. And I'm super excited to show you this technology because I think, again, this is going to empower you to pretty much build out any vision or idea that you can conceive. A little bit more about me. I love building things. That's why I got into this. That's why I got into programming. As soon as I built my first little function and I felt that rush of power, basically, I felt like I made fire for this first time. And I realized, like right then and there, I recognized how I could use technology, how I could use software development to extend my ability to do more, to solve problems in the world, to make meaningful things. And that's still what motivates me pretty much every day. I wake up in the morning and I think, you know what, I'm going to build something amazing today. And that's what gets me excited. And that's what gets me excited about this technology. I personally cannot stand when you wake up in the morning and you have a vision or an idea, all the distractions that get in your way. And this technology in particular is very good at getting out of your way so that you can focus on building your vision, getting your thing out there and delivered. So anyway, here's my contact info. You can reach out to me with any questions. It's my email. That's my Twitter account. Here's Serverless Inc. There's 17 of us. Early stage startup. If you have questions about entrepreneurship or startups or fundraising and stuff, or serverless architectures in general, feel free to just raise your hand. Probably the serverless application questions are most relevant right now, but if you want to talk entrepreneurship or fundraising or startup stuff, I love that stuff equally. So I'll hang around afterwards and we could chat about whatever. Okay, serverless. What is exactly happening here? What are we talking about? Okay, first off, there's this has become a big buzzword, and there's a movement going on around serverless applications, around serverless architectures, around doing things the serverless way. And here's a simple snapshot of Google Trends. You could see clearly a buzzword has caught on right at the beginning of 2016, and it's taken off. And I'm sure it's much bigger now. I've got to update this graphic. But why is this taking off? Like, what does it mean? Why is it taking off? And my feeling is that it solves ancient problems, problems that have plagued us for a long time. Number one, we're developers. We may own our own business, and the first thing we have to do is just get stuff done, right? That is hard enough. It's hard enough to get stuff done. When you wake up in the morning, you're going to face a million distractions, all types of things. Your creative energy is being sucked out of you by so many different factors in life, and it's just hard to get stuff out the door. So whether you're a developer or you're a company, getting stuff done is just all-time major ancient challenge that we've had for a long time. Reducing the amount of time it takes to get stuff done, to deliver value, to deliver product to the market, trying to shorten that time as much as possible. Ancient problem, right? We want to get stuff out the door as fast as possible because if you look around, it's not getting any easier to compete in this world. There's massive companies right now. Everybody has access to great technology. And if you want to move fast, get stuff out the door, well, everyone's had to do that for a long time now. They just have to do it more so than ever, I'd argue. Reducing overhead and expenses, right? Everybody likes to build. I don't think a lot of people like to maintain stuff. It's like just it's an ancient human truth. And people don't like to pay a whole bunch of stuff, a whole bunch for stuff. And I'm going to show you how to build stuff incredibly cheaply. And I will say that's the number one thing that brings people to this movement is once they realize how cheaply they can make stuff. We're talking fractions and fractions of a cent. Increasing automation. Again, I think that this technology in particular is going to allow you to automate so many things away. Again, going back to that theme of being able to do more, being able to extend your ability. Increasing innovation. You know, once we lower the barriers on our tooling, on like what it takes to actually get something out the door, all of a sudden you're able to innovate faster. You're able to come up with new stuff faster than ever. And we're going to talk a lot about that. So those are ancient problems, I'd argue, you know, in the context of human history overall. And here's kind of a brief history of recent solutions. Number one, businesses began to leverage IT to solve their business problems, to solve the problems we just discussed. And they used to buy and maintain mainframe computers, aka servers. You'd have these massive computing systems in your office, and they were super expensive. They were ridiculously hard to maintain, and very underutilized. And this used to be like what you had to do to get like your website up and running. That's crazy in retrospect. We've come a long way since then. Something that helped out greatly was the invention of the cloud. The cloud was created arguably in 2002 when Amazon Web Services first came out. And this was basically, the philosophy was, why should you own and maintain your own physical infrastructure? Why do that? Like, you want to focus on business solutions. So Amazon Web Services came out with a proposition. They said, look, we'll host and own and maintain all the physical infrastructure. You just rent virtual capacity from us. And you don't have to worry about any of that ridiculous hardware stuff. You could just interact with this physical infrastructure via these APIs that we provide. You can interact with it programmatically. And that was fantastic. That was a huge innovation because, again, if you want to solve those ancient problems, if you want to increase innovation, reduce overhead, get stuff out the door faster, you know, not having to worry about physical infrastructure, that's, you know, is great progress. However, even with Amazon Web Services, you still had, it was like a virtual representation of the physical infrastructure. And with that still came a lot of concerns around costs, how you reduce excessive expenses. There was still a lot of maintenance burden that came up with that. If you want to scale stuff out, it's hugely challenging. Like now, you don't have to worry about the physical stuff, but you still have to worry about planning for events like Chris outlined, like you know, you get on the front page of the New York Times, or it's like Black Friday or something, and everyone's hitting your website at the exact same time. You still have to do so much work with this cloud infrastructure to basically maintain it and make sure that there would be no issues once you scale. And then furthermore, underutilization. It's great that you could rent infrastructure more easily than ever, but again, there's a ton of people out there with massive AWS bills because they don't know how, maybe they just don't have the time to spend to make sure that they aren't paying for stuff that they don't use. Anyway, so it was great progress. We were able to move to the cloud, but there are still a lot of those familiar issues with this new cloud implementation. And Heroku, I'd argue, is someone who recognized this early on. And they said, look, we're going to try and abstract all that infrastructure as a service complexity that Amazon Web Services provides, and we're going to try and create a simple experience over this. And that exact same desire that inspired Heroku is what's inspiring the serverless movement today. So Heroku did a fantastic job and pioneered the way in making just this virtual infrastructure super, super easy to use so that it gets out of your way and you could focus on building your solution, delivering results, solving business problems. And serverless is kind of an extension of that theme that Heroku was after in the early days. And serverless is like, how can we investigate this theme further? We should not have to worry about scale. We should not have to worry about cost optimization. We should not have to worry about the underlying infrastructure at all. And this is what's all inspiring the serverless movement. Now, serverless is not anything different. It's not a separate concept. Think of it like a chapter in cloud history, right? We started off with this virtualized infrastructure. There were still a lot of operational burdens, maintenance burdens, cost burdens. And serverless is just like the next chapter, whereas And all it entails is how do we just offer this infrastructure in a way that the overhead, the cost, all the maintenance is dramatically reduced. And we'll dig into that, kind of what that looks like right now. So serverless, what does it mean? First off, servers power everything. The term serverless is a bit of a misnomer. It's about as technically accurate as the term the cloud. There are no clouds, powering the cloud, basically. But the point is that even though these servers exist, you as the developer should not have to think about them. You shouldn't have to worry about their maintenance or you shouldn't have to worry about cost optimization. You shouldn't have to worry about security patches, all that stuff. That stuff is a distraction. You have to worry about solving business problems for yourself, for your clients, for your own business. So this is what serverless means. Again, servers exist, but the developer does not have to think about them. And also, our company is called Serverless too. We incorporated in 2015. I had a feeling this would be a big deal. I just didn't know how big of a deal it is, and now we're kind of in an awkward position where we're named the same thing as like this massive trend. Anyway, so this presentation is about the trend of serverless and applications. And I'll show you some stuff that our company does to help you do development, serverless development more easily. Anyway, this is the big theme here. Developer time, your time should be focused on outcomes, on results, delivering solutions. It should not be focused on anything else. And this is like the golden age for being able to deliver amazing stuff with like very, very little cost of ownership. So characteristics of serverless infrastructure. Again, you used to have to worry about scale. You used to have to worry about still maintaining this infrastructure that you're renting from Amazon Web Services. You still had to worry about cost optimization. But now, these new infrastructure resources that you could use on Amazon Web Services or Azure's cloud or Google's cloud today, this new breed of infrastructure resources, first off, you do not worry about the infrastructure at all. You don't have to upgrade the infrastructure. You don't have to install an operating system. Your runtime on the infrastructure, you don't think about that at all. You simply just give it your code and it runs it. Next up, auto-scaling. You don't have to worry about scale at all. This will scale immediately out of the box to meet massive levels of scale. You don't think about that. Heroku's great innovation was this dyno concept. They really reduced the hard feat of scaling to this simple slider so you could scale up. The serverless movement is all about, let's get rid of the slider. Because why even think about that as much? Like again, you shouldn't have to think about scale. You should think about solving problems. So this stuff that we're going to build will scale almost infinitely to meet any load. Pay per use. This is the big draw of serverless application development. In other models, you normally have to pay a monthly fee for the resources that you're using. But with serverless infrastructure, specifically serverless compute, if you put your code on serverless compute, you only pay whenever that code runs, period. And you only pay for how long that code runs. And the price that you pay, say your code runs for 100 milliseconds, is 0.000001 cent, right? So this basically means that you don't have to worry about optimizing costs at all, because you will save up to 100% of cost if like your application is not receiving any hits, right? You're not going to be charged anything. But once it is receiving hits, you'll be charged like on a request basis. And you don't have to think about anything else regarding costs. And it's a fantastic model. You could scale up to 1 million requests for like $1, right? Very, very simple. And again, there's no such thing as underutilization anymore. You don't have to worry about that. So what started this new trend in how we think about this cloud infrastructure? It was an Amazon Web Services product called AWS Lambda. With Amazon Web Services, you used to have to rent kind of these virtual servers in the form of EC2. You'd have to worry about scaling those out. You'd have to pay kind of on a monthly basis. And then worry about the maintenance of those as well. But Lambda came out and said, look, you don't have to worry about provisioning the infrastructure. You don't have to worry about installing the operating system, installing your specific runtime. You don't have to worry about scale at all. And you don't have to worry about paying on a monthly basis. AWS Lambda just kind of handles that out of the box for you. So how does it work? Number one, it's microservice based. When you write code on Lambda, you simply write code in the form of a function. That is, you write code to perform one task. This task is I'm going to save a user to a database, or I'm going to send out a text message, or I'm going to respond in a voice app with Alexa on my Amazon Echo. You write code to do one thing, and you upload it to AWS Lambda in the form of a function. And you could use JavaScript, you could use Python, you could use Java, you could use Go, a handful of programming languages. And again, all you have to think about is writing your code to do that one task. You upload it to AWS Lambda, and it's gonna, you don't have to worry about administration, maintenance, you don't have to worry about scale, and you don't have to worry about costs. Because again, as soon as you upload that code, you're not gonna get charged until it runs. And once you do get charged, it's gonna be 0.00001 cent. Per 100 milliseconds. And anyway, this is fantastic efficiency. So you upload single tasks in the form of functions, don't worry about administration, and don't worry about cost optimization. Also, this code is event-driven. You could set the code to automatically react to a whole bunch of events that happen on Amazon's platform. It's very, very cool how well they've integrated this kind of like runtime as a service, this kind of like on-demand code with other pieces of infrastructure on their platform. For example, if something happens in your database, you could write some code that instantly reacts to the database change, right? You could transform, you could do some validation right there. If you receive like an email using Amazon's email service, you could write some code to respond to it. If you built some type of IoT device, you could write some code to simply respond to any IoT events that are happening. If you want to build this voice skill on Alexa, every single voice command comes in the form of event. You could write some code to react to that. So half the value is in how efficient this allows you to run code. The other half of the value is how well they've integrated it into all these other great pieces of infrastructure that you could use. So once the success of Lambda kind of took off and Amazon recognized how much demand there was for offering infrastructure with extremely low overhead and low cost, they started to refactor and come out with a whole bunch of different other types of infrastructure that has the same qualities. Like, you know, storage, arguably on Amazon has been like serverless or had serverless qualities for a long time. You only pay for what you use. They have new database products that are all priced on like pay per execution, and they auto scale. IoT platforms, you can handle 1 million connected devices and only get charged whenever your IoT platform is being used. Machine learning stuff you could do on like a pay per execution basis. All this scales automatically. There's a ton of stuff out there that now has these serverless qualities. And this is amazing because like these are the ultimate building blocks, right? Like these are like the most efficient building blocks that have ever been created for all of you to use to build some type of result, to build some type of application, some solution. Now, when I say serverless applications, what I'm talking about is combining the infrastructure on Amazon Web Services that has these serverless qualities, auto-scaling, zero administration, pay per execution. When you combine these things to make an actual application that does something, some type of outcome. It could be a website, it could be, you know, a chatbot in Slack, it could be a voice skill on Alexa, it could be, you know, Amazon has these IoT buttons, you press it and it will send an event. You could write a function, a serverless function that responds to that. It could be all types of things. So many use cases, and again, it's all about taking the infrastructure with these qualities and combining them. And once you do that, you end up with an application that has an extremely low total cost of ownership. And again, this is what we want at the end of the day. We want to build stuff fast. We want to build stuff that we don't have to maintain. We want to build stuff that can handle any type of scale, and we want to build stuff that only charges us whenever it's used. So that's what a serverless application is, combining these pieces of serverless, pieces of infrastructure that have these serverless qualities. All right, why this is important to everybody, and especially this audience. Again, I kind of mentioned it before, but these are the ultimate building blocks. These are the things that give you superpowers. And I just found this graphic right before I did the talk, but honestly, right now there are 3 times as many serverless types of infrastructure that you could use to make things. And again, these are like superpowers you could use to do all types of things. The new services that Amazon has to do machine learning, to do image recognition. You could send it any type of image and it'll process it and give you a whole bunch of data back. You could scan, you could do facial recognition. Services to send up text and it'll respond with like a audio file of that text being spoken. Real-time processing of video. Amazon has a great new little camera that they put out there, and you could kind of process like millions of these connected cameras in real time and do some type of video intelligence. You could actually recognize people in the video, you could recognize places, all that stuff. And there's a ton of these. Amazon is doing a great job coming out with basically the greatest building blocks of all time. And again, these are going to enable you to do new types of things, all types of innovation for yourself, for your clients, or for your business. And again, this is like the golden age to be a developer. If you see what's going on, there is amazing power now on the cloud with these serverless qualities that makes it very efficient. And you could use these to build anything that your heart desires. So some use cases we see a lot. These are the types of serverless applications people are building. They're building websites, very common, mobile applications, IoT applications. I've seen someone build a serverless application to basically monitor the water levels in their garden. Whenever it gets too dry, they'll simply have some functions react to this dry event and initiate the water. Building simple form processors, building all types of automation. We've seen people who build basically like this event-driven onboarding process for new employees. As soon as a new employee joins, they trigger all these functions to go in and like register them for all the company's services that they need to use. So much cool stuff. Security audits, stream processing. Nordstrom uses this technology. Every single time someone does something on Nordstrom.com, it's captured as an event and it goes and gets sent up to AWS Lambda, which is, again, the serverless compute service. And it's processing all the events that that user does, and it's creating a personalized experience on Nordstrom for them. Chatbots, super popular. If you want to build a Slack bot, serverless is like the best way to go. Again, you won't be charged until someone actually types something into Slack and you receive that event and your code runs. Voice bots, Alexa skills, all the Alexa skills, I think, or probably about 90% of them offered on your Echo, are all powered using serverless technologies, and especially AWS Lambda. Image resizing, web scraping bots, serving just regular HTML. Webhook listeners is a big one. Cron jobs, just so much stuff. And what I saw in the early days is that when you have technology or infrastructure that is this convenient and this efficient, everybody wants to use it. They want to use it for all types of things. So it immediately attracts like all types of people and all types of use cases. And it's liberating a lot of creativity, I think, that was previously suppressed by just overhead. Anyway, this is my favorite story. We've had a ton of success stories in the serverless application world. For our tools alone, like our users are Coca-Cola and Nike and Nordstrom and Expedia. But this was a story that kind of won over my heart in the early days. And I think it demonstrates the power of this technology. This story is called Census Fail. And basically in 2016, the Australian government said, look, we're going to do the census online this year. We're not going to deal with any physical paper anymore. And what we're going to build is a survey website, a simple survey website, to go and collect census data from everybody. And they contracted a very popular company that will go unnamed tonight. They contracted this company to build a survey website and make sure it could scale. And they paid this company over $9 million to build this website. And then they paid probably like 5x just to go market that this was going on, so that everybody in Australia knew that when they came home, they should go to the survey website and fill out the census information. And you know what? That's exactly what people did. They came home and they all logged onto the website at the exact same time, and the website crashed immediately. It went down for an hour and then multiple hours, and then it was down for multiple hours across multiple days. And I believe from what I've read, and I haven't checked in on this story for a long time, but they still haven't collected enough data because of the outages to make the census kind of statistically significant. Like they can't actually draw a lot of conclusions of it just because of this. Anyway, so this is a classic story, right? You want to build something and it just can't handle scale, and you've like paid a whole bunch for it. The government's very good at this, and it doesn't work. Anyway, so a couple days after this happened, this was trending under the hashtag census fail. It was all over the news. Everybody was talking about it. A couple days after this happened, there were 2 university students who were at a hackathon, and they're like, what should we build? What could be cool? And someone came up with the idea of like, let's see if we could recreate the census survey website and build it on this new serverless technology. And let's just see if we could do it better than the government and this like super popular technology company that was contracted to do it can do it. And so these 2 university students were able to build a perfect replica of this census website. And it scaled flawlessly when they tried it out. And they got a lot of recognition for this. It was like, massive government failure. And look at these 2 university students who could do it really, really quickly and do it without a hitch. And they were able to do this in 72 hours, which I think is fantastic, right? This was literally like an extended weekend. They're able to pull this off. And again, when the reporters were kind of drilling them for information, they're like, "Wow, you're able to pull this off in 72 hours. How much did it cost when you actually tried to test it against the same amount of volume that the actual census website received?" They said $200. $200. Like I couldn't believe it. Millions of requests. They hammered it. They did a big load test. They wanted to make sure that it performed against the same amount of volume that the actual website received, and even more. And our company interviewed these 2 university students a couple days after, and they said, "Look, it wasn't even $200. We just wanted to kind of raise it a little bit to make everybody feel better." And fantastic story. But here's one of my favorite parts. They've never used Amazon Web Services before. Never even touched it. They were able to use Amazon Web Services because this serverless technology is so efficient. It handles so much stuff for you out of the box that the things that you have to learn are minimized, right? It really makes Amazon Web Services in particular very accessible to everybody. And this is kind of my big message to this audience tonight. Because serverless, and we see this again and again, with this new type of infrastructure that's more efficient, the surface area of things you have to learn is greatly minimized, and it enables you to just focus on building stuff. But this technology in particular makes the power of the cloud and cloud infrastructure accessible to everyone. It does not matter what your experience level is. You could use this stuff. You could use this stuff today. I'm going to show you how to get something up and running really, really quick, and we'll run through several other examples. Okay, how to do it. All right, downside. Serverless applications are hard without tools. Okay, so first off, it's amazing that you have all these infrastructure resources you could use to create super efficient applications with very low overhead, very low cost, very low maintenance. But to actually take these things and merge them together into an outcome, it's a little tricky. First off, I don't know, how many people use Amazon Web Services here? Okay, so there's a handful of people. And I'll be the first to say it, Amazon Web Services intimidated me for a very long time because it is crazy complicated. As soon as you log in, you're just overwhelmed by this dashboard of, like 50 or 60 products that they have. You have no idea where to begin. You have no idea what it all means. There's a great drinking game you could play where you try and remember what the icons mean. But it's super, super complicated, and it's not, it just, again, this is what like Heroku identified so early on. It's like there's got to be a better, simpler experience around all this stuff. So in here are kind of older services that have more maintenance requirements, and mixed into those are like these new serverless services. But how do you even identify that? How do you know how to get started and kind of start merging these things together to make something? So Amazon Web Services is complicated. And in the early days, we kind of recognized this, and we said, you know what, this serverless trend is like bigger than Amazon. This is going to be something that democratizes the power of the cloud and really makes it accessible to everyone. But Amazon is not doing a great job of that. They created the great infrastructure, but they didn't build a great experience around it that really helps anyone take advantage of this. So we made a project called the Serverless Framework. And we did this in 2015, and this project is one of the most popular open source projects today. And I think it really kind of paved the way and really made the serverless trend a very popular topic. So it's open source. I wish to God that this thing made money, because this is like our flagship software at our company, but it doesn't. We give it away for free. It's the open source go-to-market strategy. Basically, you give away a whole bunch for free, you try and build an audience, and then later on you follow up with hopefully commercial plugins and things that extend your open core. Anyway, but we've spent years on this, trying to make it this fantastic project. Again, it's all out there for free. I've got nothing to sell you tonight. The only thing you'll have to do if you want to get started is just like sign up for an Amazon Web Services account, and they do make you put your credit card in when you first sign up, which is I don't know, I don't like it. But anyway, this is for free. You can use this right now. And it supports Amazon, and it supports Google, and it supports Azure, and any other cloud provider that is starting to offer this new serverless infrastructure. The problems that it really solves is it converts that serverless infrastructure into a serverless app, into that outcome, into that tangible result. That's the one thing it's very, very good at. And it abstracts all the complexity, that dashboard with all these services that you saw. It hides that from you because you shouldn't have to really know about it until you need to know about it. Next up, architectural complexity. There's some of it with the serverless architecture. You have a lot of different components of things. The serverless framework kind of hides all that complexity and just gives you a simple way to reason about that. Application lifecycle management. So it's going to help you get up and running, build something as fast as possible, but it's also going to help you manage that application through its lifecycle. When you have to put in updates, when you want to create a copy of your existing application and upload it in a new stage, when you want to expand to multiple regions. The service framework helps with all that. There's a local development experience so that you could start testing out your serverless application locally. There's just a great developer experience around it. I'm a huge developer experience fan, and this is something we care immensely about. We want to make it, again, this technology, it really democratizes incredible power and makes that accessible to everyone. The way to realize that technology is it needed to be wrapped in some great experience focused again on application development, and that's what we invest a lot in. Vendor agnostic options, so this is one thing that doesn't lock you into AWS. You could use this with Google stuff. Google has amazing serverless infrastructure for doing machine learning, vision recognition, video intelligence. Google is very, very good at all this new AI stuff. And we all kind of want to use that stuff because the things that we're going to be able to build with it are pretty awesome. So it's a command line interface written in Node.js, aka JavaScript. There's some simple instructions as to how to install it. Our website has a whole bunch of great video tutorials that walks you through everything. But basically our goal is just to help you deploy something as fast as possible, and you shouldn't have to look at the Amazon dashboard at any point. It offers a basic way to think about these things. And the best way we found to make this accessible to people is to describe kind of serverless development as a story of functions and events. You write functions that do things, that perform tasks. And again, you could use many programming languages to write these functions. And each of these functions has events that trigger the function. It could be something was added to a database. It could be received an email, or it's a kind of a voice command that came into your Alexa skill, or it's just an HTTP request. We describe everything that could possibly trigger this function as an event. So again, serverless is really mostly a story of functions and events. And what you're looking at right here, this simple configuration file, this will set up a full backend for your application. It'll set up some code and connect it to an endpoint. And I'll show you that in just a second. The CLI comes with a whole bunch of commands to help you, again, manage the lifecycle of your application, from creating your app to invoking it locally, running it locally, to deployment, to seeing logs of your application, to rolling it back when you made that crazy error, to removing the darn thing. These use cases, I kind of went over these already, so I'm going to skip ahead. Here's all the languages it provides just on Amazon alone. There's Node, there's Python, there's Java, C#, a lot of great options there. And the Serverless Framework has such a fantastic open source community that people are writing all types of plugins for it. So if the Serverless Framework doesn't do something that you need it to do, you can write a plugin to overwrite its functionality or extend it. And there's hundreds of plugins that people have written to extend its ability. We just surpassed 20,000 stars on GitHub, tons of enterprise users. All the enterprise companies that are already using Amazon Web Services are moving incredibly quickly to migrate their stuff and build all their new stuff on top of the new serverless infrastructure because they get it. They're like, this is so much better, it's going to reduce overhead. And then they come to us and they secretly say, and we don't need to hire as many developers, right? So let's jump into a demo. Now, I haven't played with the Salesforce platform before. I kind of glanced at it. Looked a little complicated, to be honest. And I was trying to get like a webhook working, but I kind of ran out of time. So I'm going to show you how to build, basically get a function up and running that will auto-scale in its pay-per execution, and also hook it up to an endpoint. And with that, you should be able, if you could figure this out, and I'm sure this is the right audience that can, if you can configure a webhook, to come from the Salesforce platform and trigger that, or you could actually just have some Salesforce code that calls out to that endpoint and calls your function and does something with it. It is basically the perfect bridge you need to get into the Amazon platform and take advantage of all of Amazon's stuff in a serverless way that is very, very low overhead. All right, let's do this. Okay, so I created a basic serverless application here. I ran a serverless create command. It created very, very simple scaffolding. All it's going to do, and this project is called Salesforce, of course. All the command does is it creates this configuration file that declares it as this folder, is a serverless project. And then it also creates my code file. And this is where I could start putting in the code for my functions. In the serverless configuration file, you just name your serverless project, your serverless application. You could put in the provider. Everything kind of defaults to AWS and kind of defaults to JavaScript. Again, we support a lot of different languages. You just have to change that in here. And if you want to start doing serverless stuff on Google or Azure, you just change this provider out. Next up is a functions property. And in here, you simply list all the functions that you want to deploy. There's only one function in this configuration file. It's called the hello function. And the handler right here simply points to the file that contains your code. And because this is JavaScript, you could actually export different modules from that. So if I look at my code right here, I'm simply exporting a hello module from the file handler. And that's written right in here. So it's the handler file with the hello module. So pretty simple. I got one function. Here's the code that will run in that function. And then lastly, events. Again, serverless is mostly a story of functions and events. And in here, I have one event. It's an HTTP event. And what this means is it's going to set up an HTTP URL, aka endpoint, with the path, /hello, using a get method. And it's going to take that, it's going to provision, it's going to create it on AWS, and it's going to connect it to my function so that anyone could access my function's code via that URL. Okay, so I have the serverless CLI installed. I'm going to run the serverless command, and you'll see this thing's got a lot of bells and whistles. You don't really need to know all this stuff, but it's super, super powerful. Can everyone see this okay, by the way? This is pretty good. Shows you all the commands right here, shows kind of, describes what they do, and then also talks about all the plugins that are installed. So the serverless framework itself is just an aggregation of plugins, and so when you write an external plugin, it's basically the same as the way the framework is written. Okay, so I have a serverless command, and I'm in my Salesforce folder here, and I'm going to do serverless deploy. Now, when the other barrier to entry that I have not talked about here is you simply have to sign up for an AWS account and get those credentials. I didn't cover that here because it's not super fun. And I wish we can get rid of that because it's very, very frustrating that you got to sign up for something in order. Again, everything that's in between you and delivering results should go away. Like I'm crazy about that belief. And it sucks that you have to sign up for AWS. But on our website, serverless.com, there's great video walkthroughs on how to sign up for Amazon as fast as possible and get access credentials so that you can give them to the serverless framework. I think we had a question over there.
Yeah, so if Amazon is painful, does Google or Azure any easier?
You'd think that they'd realize a clear opportunity, but I don't know what's going on. Some people are addicted to complexity. No, I think we've talked about it with Azure. We've talked about it with Google. I don't know if do you have to sign up for Heroku to get going? Yeah.
Mostly because of abuse reasons.
Right.
People like to
Same goes. Yes.
cryptocurrency on Heroku.
Oh yeah.
We don't really like that.
Yeah. And this is the reason why the big cloud providers do this at the end of the day, I think. It's because you can go up there and you have massive computing power accessible to you immediately. And you could go DDoS the New York Times or something easily. But you're prevented against doing that if you have to put in your credit card, right? Anyway, so I ran serverless deploy. The first deploy always takes a little bit longer because it's got to create resources for the first time. And we got some basic output for what serverless is doing. It basically packaged up my code and then started creating actual physical infrastructure on AWS. And that was basically it. What it returns here is some basic information about kind of my project. In the serverless framework world, your project or your apps are just called services. You can see the name is the stage defaults to a developer environment. It's being provisioned in the US East region. And here's a list of functions. Here's that hello function that I deployed. And here's my endpoint, right? Here's my tangible URL, which I could call right now. So let's put that in. And now my code, all it was programmed to do was return this message, hello world. Just like Chris's example, and that's it. That's basically it. Now what are we looking at here? What are we looking at here? This is a infinitely scalable pay-per-execution API that we just deployed in seconds, basically. This is probably one of the most powerful things that people haven't been able to have before. And this is something that all of you could leverage today. I'm not going to get charged until someone hits this URL. So I just got charged 0.000001 cent. And I just reloaded it. So I just got charged another 0.0001 cent. But again, right now I'm not getting charged for anything. And that's amazing, right? That is exactly how it should be. That is the efficiency we're looking for. You pay for what you use. And this thing will scale to meet any demand. You don't have to go and adjust anything. You don't have to set an auto scaling option. It just happens like that out of the box because again, that's the way things should work, I argue. So we've done that. Now we maybe want to do some more sophisticated stuff. I'll just do a quick change of the code. And the serverless framework has a nice command which allows you to just deploy the function that you changed. So I'm going to quickly update my function, and I'm going to refresh, and there's my quick update. Happens super, super quickly. Yeah, it's awesome stuff. Again, this is power that all of you can access right now. We just tapped the surface. Next up, the serverless framework has one other concept, and that is resources. Once you want to start getting into kind of more sophisticated stuff, when you want to add a database, you just put in your resources property and start adding in your AWS resources. The way it works is we use Amazon's CloudFormation. And on our serverless GitHub repo, we have a ton of examples to do all types of stuff. Like here's a template to do an Alexa skill. If you want to get up and running with an Alexa skill in seconds, just copy this and CD into it with your CLI and run serverless deploy. And you'll get up and running with a basic Alexa skill. There's stuff using DynamoDB. DynamoDB is a NoSQL database. It's kind of one of the preferred database options to use in your serverless architecture because it auto scales and only charges you per use. There's a simple GitHub webhook listener if you want to get into GraphQL, if you know what that is. Very exciting trends, very, very efficient. There's a basic template to do that. If you want to start doing IoT stuff, there's a template in here to start doing that. Recognition analysis, if you want to do image recognition or video recognition, copy this and run serverless deploy. Some examples to build a more sophisticated REST API with Dynamo, and we'll just take a quick look at this. Here's the serverless.yaml file. It's a bit more sophisticated. There's our typical provider information. There's some permissions that you need, and then then now we have more functions in this. We have functions to handle basic CRUD operations like create, read, update, and delete. And then there's a resource. So here's how the resources work. You just put in your DynamoDB, your database, in this fashion. Again, this thing is turnkey. It's ready to go. You could copy it right now. You could deploy it. And what you'll end up with here is a REST API with multiple endpoints, because each one of these has an HTTP event attached to it with a specialized path. And these will point to your code. What else? These functions, you could schedule them to run like cron jobs. So you could set them to run like every month. You could set them to run like once a week, once a day, once every 5 minutes or something. And again, you'll only get charged whenever that thing runs. So if you set it to run every 5 minutes, you'll get charged 0.00001 cent, every 5 minutes. This thing is a scheduled cron job that checks the weather. You could actually serve dynamic, you could serve HTML from these functions. And I have a quick example of that. And I'll plug it in here real quick. Hopefully that syntax is okay. Because I didn't actually test this out, but we'll find out. So that previous example was just returning JSON, and that example was for like building a backend or an API. This example, I just switched out the code, and now I'm returning HTML. And now I have a website. Right? I have a web page. And again, this web page is only going to charge me 0.0001 cent. Every time I hit the refresh button here. Super, super efficient. Super, super powerful.
Make it do marquee?
People, yeah. That was a very sexy demo, Chris. The answer is yes. If I paid more attention to Chris's presentation, I'd remember the code and I would paste it in here right now. Anyway, so yeah, there's that. God, there's so many examples. Here's like some basic Stripe integration, a text analysis. If you want to actually, Amazon's got a great serverless infrastructure that if you send it some text, it'll go and kind of drive some insights from that text. Like if it's a sentence, it could do like emotional detection. It could detect like, is this person angry? Who wrote the sentence? Is there someone angry? Are they being violent or something like that? Twilio, sending out text messages from Twilio. Alexa skills. There's a lot of Python examples here, and then we get into some Azure examples. But there's so much stuff you could do with this, and this examples repo is a great place to start. You can get it up and running really, really quickly, and again, these applications are going to be more efficient than anything else that's out there. That's it. That's it in a nutshell. So if you have any questions, I'll hang out and ask. But again, the big message I want to leave you all with is that this is the technology that makes the power of the cloud accessible to everyone. And if you're looking for an opportunity to do more interesting stuff, to create new types of innovations for yourself, for your clients, for your businesses, like this is what opportunity looks like. And this trend is just getting off the ground. It's still just the very, very early days. But everybody is obsessed with it because they recognize like this is a clear 3x gain, right? This is like clear progress. So, I hope that you check it out, and I hope that it enriches your life and allows you to kind of like build out your vision and your ideas more easily than ever before. Hopefully you'll take it and make some meaning out there in the world.
We've got the venue for another 15 minutes. Do you want to do a quick one or two questions? Does anyone have any burning questions?
So does Lambda have serverless built in, or do you have to do it on the side and configure it?
Yeah, so Serverless is a way we describe certain types of infrastructure. So serverless isn't really like its own piece of infrastructure or anything. Instead, you look at these pieces of infrastructure and you say, ooh, that one is kind of serverless because it has these qualities. It's basically kind of like a criteria. So the qualities of serverless, again, are auto-scaling, pay-per execution, zero administration. And Lambda has those qualities. Again, it'll scale to meet any demand. It'll only charge you at a sub 100 millisecond basis whenever it runs. And you don't have to worry about the underlying infrastructure that powers Lambda. Therefore, people refer to it as serverless. To answer your question, it's, serverless isn't type of infrastructure or anything like that. It's just a way of describing certain infrastructure that has specific qualities. Yeah.
Given the fact that you're making a framework for all the cloud services, does that become hard to keep up with whatever they're building out as a result? If another competitor comes out, I noticed that you can have Alibaba cloud, but if you had another one trying to come out, is that the hard part of being a framework for you guys?
It's a pain in the ass, to be honest, especially for a free tool, right? Actually, it's not that bad because given the size of our community, the cloud providers actually maintain their own integrations now into the project. So Alibaba, I think we announced the integration already, but they kind of wrote that whole thing into the framework. Same goes for Azure and some of the other big providers. And I like it. I'm very excited about this. As a developer, again, as someone who's just like obsessed with getting stuff done and building things, I don't want to be stuck with one platform. When I look at all these big cloud providers, in addition, like all the great SaaS that's out there, like Stripe for payments or Twilio for communications infrastructure, I just want to be able to use whatever I can use to solve the problem best, right? If Google is offering something that's really, really great, and again, they rock at machine learning, they have a ton of valuable data, they're going to be probably like the go-to place to do machine learning AI stuff for a while. I want to be able to bring in that, I want to be able to use that stuff. Same goes, Amazon, of course, Alibaba. I don't know a lot about their platform, but if they have something that helps me solve my problem best, then I want that option on the table. So this is mostly why we do it, because serverless is about outcomes, it's not about infrastructure, and you should have every option on the table to help you kind of build your desired outcome best.
So are they the ones that contribute to your framework then the most, would you say, typically?
The cloud providers in general?
Yeah.
I'd say they do a lot, certainly. Open source is such an amazing thing. About 70, and we actually monitor this and measure this, about 70 or 75% of all the contributions to that project are done by volunteers, or by people outside of our company. A lot of that is big cloud providers, and I'd argue more of that is just by people in the community who want it to do something that it doesn't do yet. So it's an incredible thing. We have people just coming by all day long and they're solving problems, and we only do about 25% of the work now. Yes?
So, check if I understand correctly. So basically the serverless, your website, basically auto-configures AWS or whatever the service that I'm actually paying for. So it's essentially once it's configured, I don't really depend on the serverless website anymore.
Yeah, you don't depend on us too much. We're basically kind of like this lifecycle tool. You're not actually depending on us for the infrastructure. We help you use other people's infrastructure. So you kind of depend on us when you want to make changes and stuff like that. But otherwise, all this thing is doing, all the serverless framework is doing, is it's going to Amazon and like setting up stuff for you, provisioning all this stuff. It'll roll it back for you safely. It'll remove it when you want to remove it. And it does all this because it's too complex on Amazon, right? You shouldn't have to go there. Our mantra is like, you shouldn't have to use the AWS dashboard.
Go to Amazon and see all the code and change what's code there, although
Yes.
that would be awkward for serverless, because then it would not know what I did there.
Yeah, it would. We've built in some support, so when you go into the dashboard and start monkeying around with things manually, hopefully we can detect it. But yeah, that option is still available too. And it happens all the time. If you want to like go into that dashboard, and that is where you'll get a great logging experience. That is where you just have to do that sometimes. Yeah.
So you said earlier, I can, on one project on my own account, I can mix and match. Like I can get some service from AWS, get some service from Google, and take the best from both, or from all the services.
Yes, right now a project has to use a specific provider. So you can't kind of mix things yet in the same project. But that's what Serverless Framework version 2 is all about. So that's coming. And that's going to be all about not just like I want to combine stuff from Google or Azure with my Amazon project, but I also want to be able to easily bring in Twilio. I want to be able to bring in Stripe. I want to be able to bring in, like Salesforce stuff really, really easily to my project.
But technically, since that's a lot of it is just URL, like REST APIs anyway, I could make two projects that talk to each other.
Yeah, oh, absolutely. Yeah, there's a lot of ways you could still build things to communicate to each other. Every single big cloud provider now has something like AWS Lambda, where you simply upload code in the form of functions. They scale for you, there's zero administration and pay per execution. So Amazon has Amazon Lambda, Google has cloud functions, IBM has IBM cloud functions, Azure has Azure functions, and they're basically kind of all the same thing. And I think of them as like a great entry point into that platform. Like if you want to adopt Google Cloud and start doing stuff and using all their great services, start with their Google Cloud functions. Because all you have to do is upload some code, it's auto-scaling, pay per execution, and from within that code you could use any of their other services. So it's a very cool starting point to get into a big cloud platform and start using all their stuff. Yeah.
How would you describe your biggest customers? Like, I mean, if you went really at a high scale, like one of these, online sales or a media company, and how small does it get? I mean, where are you finding most of the consumers of this?
It is not a specific vertical thing. It is, again, very, very powerful, accessible technology that spans industries. So we see, we see so much stuff. Nordstrom is a huge user. A lot of the stuff is increasingly powering Nordstrom.com. We have like a few government agencies. What is the, I can't remember the name of this agency, but they basically have to process every single stock trade that's out there. And they're now doing 70% of all stock trades out there with AWS Lambda.
Securities and Exchange Commission?
It might be them, yeah. What else do we see? Media companies. There's a startup called A Cloud Guru. Their whole platform, it's basically a video tutorials for Amazon Web Services. Their whole platform is built on serverless stuff.
If you have a high volume site, like you're a big newspaper or something, what are you doing today? Are you leasing directly from Amazon or something? Or?
Yeah, they're probably using Amazon Web Services. If they've made that leap to the cloud, and a lot of companies still haven't, right? They're actually still kind of running their own physical infrastructure or running that from some other service or something. But the people who are using AWS, most of them are trying to figure out how to migrate to a serverless architecture kind of as fast as possible. And I think they're just waiting a little bit for best practices to emerge, for more serverless resources, but they all want to get there. Nike has a bunch of high-profile sites like running on this stuff right now. Coca-Cola, back in 2016, I had a conversation with them and they said, look, every single one of our marketing projects in North America are going to be serverless by the end of 2017. Like, we want to move over stuff as fast as possible. So a lot of greenfield stuff. The migrations, I think, are just waiting a little bit longer for, again, like I said, best practices and for the technology to mature. But it's already very, very powerful. And again, we see people trying to move over to it as fast as possible. Yes?
In this example in green, it looks like
service was successfully published, and it's hitting serverless.com. How is that interacting with this example? Now, it's not just your machine and Amazon, but it's serverless.
Right, yeah. So we have a beta product called our Serverless Platform. And it's basically a graphical user interface that kind of helps you visualize your serverless project. So when you deploy something, again, you're not relying on us for your physical infrastructure. But what we do provide is this user interface where you can go click on that and kind of see like your functions and the resources and the events, how it's all wired up. But it's still under beta. It's one of our commercial experiments that we're conducting. Yes?
Yeah, so that auto scaling sounds like fun, but that scalability part, is that handled by the servlet layer or is that up to the cloud?
It's handled by Amazon. So they make sure all that stuff works so that you don't have to. So that's what Lambda is all about. Behind the scenes, they have a whole bunch of auto-scaling logic that's working for you. So you don't have to think about that. Yes?
What would you say to a migration question? All these people who have like a little shopping site set up on WordPress or Drupal or things like this, migrating them over to this, is that going to be very painful?
The great thing about this architecture is it's inherently something called a microservice architecture. And microservice architectures are all about, we used to design applications as these big monoliths, like these code bases of like hundreds of thousands of lines of code. And it was a lot of stuff all interconnected as a code base is. And whenever you needed to make a change, you risked affecting all other parts of your application. So then, several years ago, we just said, look, can we start breaking up these big applications into specific services? Basically separate, smaller applications that all work together. And then it kind of moved on to microservices, let's just try and separate every single piece of logic in our application so that we can make updates and changes that only affect or risk this specific component without affecting or risking the system as a whole. That was the microservice movement. And the great thing about Lambda is that it's inherently kind of a microservice architecture. I literally have all my logic isolated in these independent deployment units of functions, basically. My hello logic is in the hello function. If I wanted to build a backend for saving users, deleting users and stuff, I'd have a create user function, I'd have an update user function, and a delete user function. And when something is wrong with the delete user function, I just go in and I modify that function and I fix it. And I'm only touching that little piece, right, without affecting anything else in my application. And that is a great position to be in when you're building something that has a lot of traffic, that has a lot of users, and you just don't want to mess anything up, right? But what does this mean for migrations? It means that you don't have to think about moving this whole project over. Instead, you could think about, I'm just going to move over this bit of logic over into a serverless architecture. And you could sort of piecemeal, start moving stuff over selectively and test it out. And it's a very, very low risk way of doing things. Now you have to think about things differently depending on how your legacy architecture was designed. It might be a big monolithic application and separating out logic might cause some head scratching. But this allows you to do it in a piecemeal fashion. So you could at least start testing it out without affecting the whole thing or trying to figure out how the heck to move this whole thing over. But yeah, WordPress sites, yeah, I know. Yeah. So there are some projects out there that allow you to run WordPress in AWS Lambda. So I've seen some experiments like that. They don't support PHP with Lambda yet, which I think is the big barrier, but I'm sure that's coming, right? And it's going to enable people to kind of start running WordPress in this pay per execution fashion. And I think that'll greatly help the migration story. Yeah, okay. Anything else?
We have to get out, so.
Oh, time's up. Thank you, everyone.